Okay, good afternoon, guys. It is time for science. We have a small group this afternoon, so it seems like some of you are going to just be watching the playback of this. We're going to be doing a lot of mystery science today. Before we get started with today's lessons, I just wanted to I was going to review last week's quiz, but I cannot review the quiz yet because a couple of you have still not taken the quiz. Now, I know that it was messed up for a large portion of the week and it wanted you to enter numbers, and it wasn't questions that were supposed to have numbers as the answer. So I did get it fixed. It is fixed now. I was hoping everybody could still get it done by the end of today at the latest, so that we can get the grade book, because that quiz is for a grade in the grade book. If you've already taken it, I have your scores, and I think if you log back into the document, it will show you your score, or I can send it to you on GoGuardian, however you prefer, or send it to your parents. But so if you did it, I did go back in and grade it because it doesn't really grade it on its own very well. So I go back and double check everything that it graded and then check the ones that I need to grade. So overall, we did okay on last week's quiz. Those that have taken it, Kane and Jason, I'm definitely still waiting on yours. And Grace, I think you took yours on paper with Miss Beckett, so I've got to get that from her. But everybody else, thank you for getting it done. Like I said, I know it was kind of a last minute thing, me getting it fixed. Couple of issues this week that we haven't had in the past. So thank you guys for being patient. I do appreciate it. All right. That being said, I want to go ahead and move on with this week. We're doing mystery science. I had sent something earlier in the week to you guys on an inbox message that said, if you can print these things, print them. And if you can't print them, I've got them at the school for you. But if you don't have them at all, hang on, guys. If you don't have those papers at all, don't worry. If you do have them, fantastic. You can actually participate in today's activity somewhat. But if you do not have the papers, that's okay too. You can at least watch the activity being done, and we're going to discuss it together, all together, okay? So that being said, we're going to switch over. Hang on, somebody's messaging me on GoGuardian. It's the dearest Josie. Can I send what on here? What you asking me, Josie?
Science.
Can I send science on GoGuardian?
Yes.
No, I don't think so. It doesn't let me attach anything in GoGuardian. Oh, the score? Yeah, I can send you your score.
Right.
Yes. Cam.
Can you send me mine too?
Yes, I will. So right now I'm going to flip us over and I'm going to present my screen, and we're going to watch Mystery Science. We're going to watch Mystery Science together, and we're going to do one of the Mystery Sciences together today. There is a second Mystery Science that you are going to watch and do on your own. And then there will be a quiz at the beginning of the week. So today you'll have Mystery Science, and we'll do it together today. Tomorrow you'll have just a Mystery Science assignment to do, and then Monday you'll have a little experiment to do and the quiz that'll pop up on Monday, okay? So lots of Mystery Science to do this week. There are 2 Mystery Science lessons, but they really go kind of hand in hand because they kind of go over similar things. Josie.
So I wanted to know, you with the shadow thing, you only have to do it like once. Like I did mine on Monday, and then next Monday, do I have to record it?
Yeah, I want you to just look at it and see, and we can kind of talk about how your shadows are moving. I don't know that I'm going to get everybody to participate and continue to take a picture, or if the Post-its even going to stick for that long, or what's going to happen with it. But as long as we can get the Post-its. Okay. But yeah, as long as we can get it to stick and try and check back with it, I would be interested to hear what's happening with the shadows in your house as we're going into the fall. I think we will definitely see some changes. So that was my hope, is I just wanted you guys to see how shadows change over a period of time and not just over the day. We know that from morning time to the nighttime, the shadows change, but seeing how that same shadow changes over the course of a week or two is a whole different way that a shadow changes. So that was kind of the point of that experiment. It's just that it's kind of a long experiment because you just kind of have to wait for a while. But for now, today we're going to talk about, last week we talked about how the Earth moves around the sun, right? But the Earth also moves in another way, right? It spins around its axis and that imaginary pole that goes through the middle of it, right? And so today's lesson, we're going to start talking about the Earth spinning on its axis and what kind of effects those have on our life and the sunshine. So let me, hit present, and we'll go through this together. Hopefully it works and I don't have any more technical difficulties. This entire week, I feel like, has just been lots of technical difficulties. Like, it's gone really smooth, and then this week it kind of just like, so here we go. Well, thank you. All right, can you guys see the Mystery Science screen?
I can.
Okay, here we go. Hopefully it's loud enough this time.
Hi, it's Doug. I've got a question for you. Have you ever been on a train? Well, I want you to imagine that you're boarding one. You find a seat, maybe start taking a little nap, and then at some point you wake up and look out the window, see this other train on the track next to you just zipping past. It's going like 70, maybe 80 miles an hour. You think, wow, that train is moving really fast. But then you realize, wait a second, maybe that train is standing still and your train is the one that's actually moving. Whoa. Now, it seems like it should be easy to know when one thing is moving and the other thing standing still. But as this train example shows, there are times when it's not easy. Here's a similar example, this time something that happens every day. Every morning, the sun rises in the east and follows this arc across the sky. Then, in the evening, it sets in the west. It's the sun's daily pattern. Now, is the sun actually moving as it does this? Or are you moving and the sun is standing still? I know. You might think you already know the answer to this question. It's the Earth that moves, right? You've probably read in a textbook or heard your teacher say the Earth spins or rotates around its axis once each day, making the sun appear to move across the sky. The sun isn't actually moving. But don't just assume something is true just because someone told you so. Really think about this for yourself. I mean, think about what a strange idea that really is. After all, if the Earth is moving, wouldn't we be able to feel that? For most of history, we've assumed just the opposite. That the reason it looks like the sun is moving across the sky each day is because, well, maybe the sun actually is moving. That's way easier to assume. It looks like it's moving. How do we know that the Earth is moving and not the sun? What do you think?
All right, so let me, where'd you go? Come back. So what do you guys think? How is it the Earth moving? Is the sun also moving, or just the sun? What are your guys' thoughts on that question? Josie?
I'd say that it's the Earth moving, but it's probably a little bit of the sun too. I mean, because one can't work without the other, so I mean, why would it not? It would affect the same way, I guess.
Okay. So you think maybe they're both moving a little bit?
I'd say the Earth is moving more than the sun, though.
Okay. All right, Fiona, what do you think?
The sun's not moving because of the way where it is. Because if it was moving, it would only be moving in a very, very little circle. But it's not. It's staying still, and we're the thing which is moving around it. But the only reason why it looks like the sun's moving is because of how fast we're spinning.
Okay. All right. So, and Josie, you said too, you kind of disappeared, so I don't know if you can hear me right now. But Josie said she thinks the Earth is moving more than the sun. Fiona, you say the Earth is definitely moving and not the sun. But you both are saying the Earth is moving. What, and like the video said, like Mystery Doug said, we've heard that the Earth is spinning on its axis before. If I even go grab my globe, I can spin it around that pole. Like you guys have seen the globe before, and we can spin it. So, but how do we know that we're moving? Because if we were moving that fast, Fiona, wouldn't it feel like there was wind every day?
Yeah. But the only reason why we don't
Is it
feel
windy out there right now? Do what, babe?
the only reason why we don't feel the wind when we move is because of how much gravity there is on Earth.
Okay, so gravity's holding us down so strong that we don't feel the wind going by.
Right.
But we
And
are
because of
spinning.
the atmosphere.
And because of the atmosphere, tell me about the atmosphere. What about the atmosphere?
The atmosphere is where it's hard to pull stuff in and it's hard to let stuff out because the atmosphere is what makes the gravity and makes it like a magnet to where we stick on the ground.
Okay.
Literally.
So you're right that our atmosphere kind of is like, it's in between us and space, right? So we're here down on Earth, and then we have our atmosphere. It makes up like our oxygen, and up in the sky, we've got the clouds, and then we get outside the atmosphere, and then we're into space. And so like, yes, everything that seems like earthly is contained in our atmosphere. When we get outside the atmosphere, it would be space. It kind of is a barrier between us and space, like you just mentioned. The atmosphere doesn't necessarily have to do with gravity, though. Gravity is actually coming from the Earth itself. Kane, what are your thoughts? Why am I not feeling all of this wind? Fiona and Josie are sure we're spinning around. So how come we don't feel all this wind? Fiona's not wrong with the atmosphere, but it's not how she worded it. So can you help her out, or do you have any other ideas?
Well, maybe we just don't feel the wind because the whole entire atmosphere is moving with us. It just feels like we're all moving together. You don't feel any wind. There's no wind at all. They're just all moving.
Winner, I hope you have a chicken dinner, Kane. The atmosphere that Fiona talked about, so that's, the air around us, even the air outside that we are breathing and walking around in and playing in. We're looking at Fiona, like if you can see Fiona on your screen right now, Fiona is sitting outside, clearly. And I don't see, there might be a teeny little breeze here and there, but it doesn't look like her hair is blowing or she's like having to hold on tight because it's super windy out there. I don't see that tree behind her really blowing at all. So it doesn't really look like it's a very windy day out there, but yet we are moving. But the reason we don't feel like we're moving is all of the air that's around Fiona is also moving at the same speed that Fiona's moving, the same speed that we're all moving. Everything on Earth, including the atmosphere, the clouds in the sky, all of it is all moving at that exact same speed as we spin. Great thoughts. But Josie still thinks that maybe the sun is also going to move too. Or have you changed your mind, Josie? What do you think? I see your hand still raised.
I was thinking because if you did, since it's moving 19 miles per hour, you would pretty much like fly off into space. And then with the atmosphere, wouldn't it be, is that like, whenever you see a space documentary or something on TV about space, there's always the fire. Is that you going through the atmosphere?
Say that one more time, babe.
Whenever you see something about space on TV and they're in a rocket ship and they go up into space and it has the fire, is that the atmosphere pushing you back?
Oh my God.
Like, what do you mean like there's the fire in space, like from the rocket?
Yeah, because it's going so quickly and it almost has fire.
Oh, like if something's coming back into the atmosphere? You mean?
Whenever you go out.
Okay, so if you're leaving the atmosphere, you're probably in a rocket, right? because I think that's the only way we can get like through the atmosphere. Yes, because we need that propulsion to push us off in that force, right? And so rocket is the only way we can get enough force to get us through the atmosphere and that far away from Earth. So we're in a rocket, but yes, part of that is they're burning all of this rocket fuel, and as they burn the rocket fuel, it is pushing away from the rocket. It's expelling all of this away from the rocket, which is then pushing in the opposite directions, creating a force in the equal and opposite direction. And it's pushing the rocket out towards space. So there is fire because it's burning the rocket fuel that's inside the rocket, I think. That could be something that we kind of look up just to be sure, because I am certainly not a rocket scientist by any means. I am just a lowly fifth grade science teacher.
The sun.
But I have
For the sun, I don't think it really moves much, but whenever I said, I think it does tiny bit, just really small, because the Earth needs the sun to like do everything. It needs the sun, so if Earth is spinning, why wouldn't sun be spinning?
Okay, so you're saying that the Earth and the sun have this relationship that's kind of like a give and take, like equal kind of relationship. Okay, all right. So let's see what Mr. Doug has to say about it.
Oh,
go ahead.
Just barely.
Okay, so maybe it's just barely.
I think the sun is just like barely moving.
All right, let's see what Mr. Doug has to say. Let me flip back over here. Okay. How do we know the Earth is moving and not the sun? We've got some theories. Here we go.
A long time ago, back in ancient times, when people saw the sun moving across the sky, everyone would have told you that's because the sun is actually moving. For example, the ancient Greeks assumed that the sun was going in a circle around the Earth once each day, like you see in this diagram. We could call this the sun moving idea. People accepted this idea for thousands of years. Two early scientists by the names of Copernicus and Galileo came along and said that they figured out some reasons for thinking that the Earth is what's moving, not the sun. These were some of the first people who came up with this idea. The Earth spins once each day around an imaginary pole, the Earth's axis, and that the sun stays completely still. We could call this the Earth spinning idea, or scientists today call it the Earth's rotation. At the time, many people disagreed with them. After all, it doesn't feel like the Earth is moving. This started a big debate. Both ideas definitely would explain why the sun appears to move across the sky. So how do we know which of these ideas is true? How did we figure this out? Well, almost no one agreed with these scientists at the time, only a handful of people. And you can kind of understand, right? I mean, to those people, it seemed like such a weird idea to look at this and say that the sun isn't moving. People would say to Copernicus and Galileo, look at it. It looks like the sun is moving. And besides, if the Earth were moving, wouldn't we notice that here on the ground? But remember the train example. It's not always easy to tell when something's moving, even when you're on it. Copernicus and Galileo had collected a lot of evidence and done a lot of thinking to figure out that the Earth moves. The details, if you're curious, involve part of science called physics, and also some high school level math called trigonometry. But today, since we're living in the 21st century, there's a much easier way to prove that the Earth is what's moving and not the sun. And that's to get off the Earth, to go into space. If we were to get far enough away from the Earth, we should be able to actually see the Earth spinning. And we've done that. This is a robotic spacecraft launched by NASA back in 1995. In fact, they even named it Galileo after the famous scientist. It was sent to study the planet Jupiter. But just a few hours after it launched from Earth, NASA turned its cameras back towards the Earth and had it take this video, which we've shown sped up. You can see the Earth rotating. If you look closely there, you might even notice the continent of Australia go by. Here are a few recent snapshots taken by a NASA spacecraft.
Whoa.
This one beyond the orbit of the moon. You can notice the moon moving by in each image. But behind it, you can clearly see that's the Earth spinning. So there you have it. Video proof that the Earth spins. By going up into space and looking back at the Earth, we can see direct evidence that the Earth is moving, not the sun. Galileo and Copernicus would be proud. Just like the train example, we may not feel the Earth spinning because it's moving so smoothly. Still, in order for the entire Earth to do one complete spin in a day, that must mean the Earth is moving pretty fast. How fast exactly do you think the Earth is spinning? What do you think?
All right, friends, hang on a second. I'm gonna pull this out, minimize it. Okay, friends, and I am pulling this out to you. Okay, so Kane, I can't wait to hear from you. How fast are we spinning? You said the atmosphere and everything, we're all moving together. We must not be moving that fast because surely it just seems like we should feel it, right? Or no? What do you think?
I think I remember reading that we spin about 19 miles per second or so.
19 miles per second. That's pretty fast. If I had to think about it, that's like, okay, if you guys have ever driven from here to what, like maybe Arnold or even South County, that's about 19 miles, maybe somewhere in between Arnold and South County. And so could you imagine making it that far in 1 second? Do you agree with Kane? Is there any way the Earth is spinning that stinking fast? Grayson's nodding his head. He's like, yeah, Kane's got this. I trust my man. Fiona is like, I don't know. I've got another theory. Fiona, tell me, what do you think?
I think it is moving that fast, but the only reason why we don't feel it is because of the atmosphere and we're all moving together, like Kane said. And because we're so big, that's why Earth is so big. That's why we can't tell that it's moving, or it takes a little bit longer than what we would think.
Right. Okay. Because I like that you mentioned because we're so big, because Earth is so big and we are so tiny on the surface of the Earth. We can't see anything other than the sun as far as a frame of reference. If I were to turn right now, there are lots of things in the room that I can tell aren't moving. And so I know that I'm the thing that's moving because I know that everything else is standing still. But when we're standing on the Earth and we look up in the sky, there's not a lot for us to look at, especially on a clear day. There's no clouds or anything. How can we tell if we're moving? There's no thing that for us to look at to know if we're standing still or moving or not. So, okay, Kane says 19 miles per second. 1 Mississippi, we're in South County. That's crazy. Okay, Josie, what do you think?
I like Fiona's idea. I think that we are moving 19 miles per second. I like, but that it's because of the mass too, I think. And are so small on the Earth that it'd be bigger. It's really, really big compared to us. So just one person couldn't feel it. That probably would have been the greatest thing if you saw the Earth moving up in space. Right? So cool.
Right. So you think if we were right, that would be very cool to be up there and be able to see it and have that proof. So Fiona then says, because Earth is so big and we're so small, and you guys are kind of like, you're kind of thinking through that and you're like, yeah, that kind of makes sense. So then if I could find a big enough person, like world's tallest person, would they be able to feel it more than you or I? If maybe there was some in the future, some person, and we could get them to stand really tall. What if we go to the top of the tallest building and we put the biggest person on top of the tallest building? Then would they be able to feel a little bit of that movement, that 19 miles per second? Josie, what do you think?
I don't
Kane's like, no.
I don't think so, because they're still in the atmosphere. And the building it's not like out of the atmosphere. It's not like their head would just go out of space.
True.
Okay, right.
Not possible if they're still in the atmosphere.
Okay, so you're saying then, Josie, we would have to be so tall that we would be leaving the atmosphere before we would feel the movement. That's what you're saying. Kane, yes, sir.
I don't even think it's possible for somebody to actually feel it really and just go up there and feel it, because there's not enough air even just below the atmosphere to even breathe in the first place. So
Well, can I put an oxygen tank on?
you could.
Yeah.
Then can I?
But then you wouldn't be able to feel the air because of the oxygen
He's
covering
right
it.
about that. The,
You're right,
the higher you
Hannah.
go, there's not enough oxygen up there. That's why, astronauts have the whole suit and space helmet and whatever. So you're not wrong, Kane. You're totally right. Like, we would definitely need like some oxygen and a space suit and whatever. The pressure is different. The oxygen is different. There's a whole lot of other factors. Kane is clearly like that in his research. He's ready to go to space, be an astronaut. But so there are a lot of other factors. But Josie's saying if you wanted to feel it move, you would have to be so tall that you were like halfway on Earth, halfway in space, basically. Kane says you can't just do that as a person because oxygen and pressure and everything else. Like, so no, there's basically no way. Fiona, your hand is raised. What are your thoughts on this?
My thoughts are that
Did we steal your words?
yeah. Again, I forgot
sorry.
the question.
Short-term question loss, Fiona. It's okay. All right, so let's go back to Mystery Doug and see what else he has to say about this. Okay, here we go. Okay, so here's our activity. We're going to watch through it first, and then we'll kind of discuss it. And if you want to act it out, we can.
In today's activity, you're going to be a human model of the Earth. You'll spin around and model what the Earth looks like while it's rotating. You and a partner will make some observations to understand how this spinning explains why it looks like the sun is rising and setting. But you'll also discover that the speed of the spin affects how many hours are in a day. I'll show you how to get started step by step.
All right, so
Find a partner.
no, we're
If
not
you're
going to do
working
that.
alone, that's
Zip it. Okay,
you'll need
he's
to get these
also,
supplies.
you do not need all of these supplies.
Mhm.
You do not. You need these 2 pieces of paper.
My nose burns.
And you might need tape. But again, like I would say tape, I'm going to use tape and these 2 pieces of paper. That's what I'm going to use to get it done. Oh, and you might want something to write with, but you don't really need that either. Lucas, if you don't have it, it's okay. Lucas, I think your mom messaged me that you guys didn't get it printed, haven't made it up to school. That's okay. If you don't have the papers, just watch the activity. I'm going to try and stand up and model it as they're doing it, so you'll be able to see me on the side. And then those of you that can do it, the papers are still up here. So if you want to come up and grab papers and do it like later today or tomorrow or whenever, you certainly can. But at least watch it because it's going to help you a better understanding. Okay.
Can't get up.
Even if you don't want to do it right this moment, you can always do it later this afternoon or evening or tomorrow or sometime next week. Okay.
I already
So let's
made
just
this.
You and a partner are going to color the sun yellow.
No, we're not.
This will help you focus the sun spin during the activity.
Nah,
Now, you don't need to spend
we're good.
cut along
We're
the.
also good.
Okay, place your two maps next to one another so that it looks like a complete map of the Earth. Looking at these
Okay.
maps, locate.
Okay, so really what we need to do is look at North America and put an X on, if you're going to participate in this, just put an X on North America, kind of in the middle about where, and if you look at it, Missouri's actually on there. Put an X on Missouri. I put a little star. Can you see? I put a star on mine where Missouri. That's just so we kind of know where we are on the map. Okay, we're gonna continue on. That's really all you would need to do there.
Okay, let's also find a location that's on the other side of the world from where you live. Place the map with the colored circle underneath the other map. Hold both of them up to the light and locate the circle. Keep track of where it is by placing your finger on that spot. Then use your crayon to color in another circle about the same size as the one on the page, like this.
Okay, so I'll give you guys a second to do that. So basically, I made my star. And again, if you don't have this, just follow along and just watch.
Are we supposed to be doing it?
You can go ahead and do it if you want to. If you want to just watch it and see what happens, you can do that. If you have the stuff and you want to do it, go for it. Okay. But I had my star on, I just put it on Missouri. I didn't go to the trouble to try and find like anything smaller than that. And then it said to take the other side of the world that had like Asia, Europe, Africa, whatever, put it on there. If you hold it up to the light, you should be able to see that little star or whatever you put. And then, so then I made a star. It should be pretty similar to where mine is, somewhere in Asia.
Yeah.
About right there. Okay. And so I've got my two maps and they both have a star on them. So where we're at and where on the exact opposite side of the world. So that is actually, I believe, China. So if we were to drill straight through the earth, we would pop out right there in China. Okay. So that's the exact opposite side of the earth is where you just put your star in Asia.
Miss Bab,
Yes.
can you hold yours up because mine didn't print the states?
Which one? The Europe one, the Asia one?
No, the North America.
The North America one?
Where to put it?
You go just a little bit left of Florida up.
All right, that's good. Thank you.
All right, we're good. Okay. All right, so you got your stars on there. You got your maps. I'm pretty sure he's going to say that the next step is that we've got to tape these maps to our bodies because we are going to become the earth.
Okay, turn the two maps like this with the arrows
We don't
facing
have
one another.
to. We don't have to do.
Okay, pick up the maps like this.
Oh, wait.
And hold them up so that your location is facing forward. Gently put the maps over your head like this.
I'm not going to do that. Here's what I'm going to do to help demonstrate. I have just tape. Okay. If you want to do it their way, you have to cut that strip off the edge of the paper and then you tape those strips together. I am just going to take the paper and just tape it like right to myself. That's what I'm going to do because it's still in the same place as it would be as if I did those strips, right? Everybody cool with that? And I'm going to attempt to tape this to my back. We'll see if I can do that all by myself in here. I don't know if you guys can do it either, but I'll put some tape on here. Got my tape.
Wrong side. That's fine.
Let's see. Let's see, did I do it? Sort of. I've got paper on my back. Okay. So I will give you to Kaylin's ready. She's got paper taped to front. She's ready to go. Awesome job. Awesome possum. Everybody that's wanting to participate, are you caught up enough? I see Fiona's getting some tape going. Okay.
There we go.
There we go.
All right, Josie's got some tape. I'm waiting.
Fiona's frozen. Oh, no, she's not.
You can keep on going. I'll just do it right now.
Okay. All right, so here we go.
Find a space behind a desk or a table where you and your partner can spin in place.
You don't
Try
have
keeping
to.
an arm's length between the two of you so that there's enough room for both of you.
First off, we're not near anybody. You don't have to be near a desk or, well, I know why they want you near a desk or table, but it's okay. That's fine. You just need to be able to stand up and spin, really.
All right, before you start spinning, put the sun model on the desk between you and your partner. Each of you should make sure that you're now turned to face the sun. Then discuss this question with your partner.
Okay. So at this point, if you have the sun, I don't have a sun one sitting here. I'm just going to pretend that my computer screen, that you guys are the sun. And if you guys also want to pretend that the computer screen is the sun, you can. And honestly, even if you didn't tape these papers to yourself, you could just pretend that the front of your body is North America and the back of your body is China. And you could do this with us, right? So even if you don't have the papers, you could still do this and just pretend North America in the front, China in the back, okay? All right, so I am North America, I'm the Earth, and I'm facing the sun, which is my computer. If I am looking directly at the sun, and you guys are looking directly at the sun, facing the sun, our little star right where Missouri is facing the sun, what time do you think it would be right now if we're straight ahead from the sun? What time would that be? Josie, what do you think?
It would probably be summer since we're directly in front of it.
It would be summer, maybe, but what time of day? What time of day, Grayson? What time of day would it be?
Probably like noon.
Probably noon. Why do you say noon?
Because if it's in the middle of the sky, then noon is your middle of your day, and if the sun is in the middle of the sky, then that means that it could be midday.
Right. So if you're thinking about, okay, I'm standing right here, the sun is straight ahead, straight up and down from me, you're right. It should be about noon, middle of the day when the sun is at its highest and we see it the best, right? Okay.
Both of you slowly spin to the left until your back is towards the sun. Because you're pretending to rotate like the Earth on its axis, you want to make sure that you just move your feet. Don't turn your head. Then discuss this question.
Okay, the next question. So you would, like you said, I don't know if you can see me. I can move my camera a little bit maybe. Okay, so you can get my face a little bit. Okay, so if you guys are my sunshine, and he says slowly spin to the left, but I'm not allowed to turn my head, right? My head has to stay straight because the state of Missouri can't turn its face, right? It can't do that. So I'm Missouri. I've got to stay facing the same way, and I'm slowly turning until my back is here. Now what time is it? Now China is directly looking at the sun, and I am facing the opposite way. What time is it now?
Night.
Nighttime. Josie, I see your hand raised. Can you be more specific than nighttime?
Me?
Yeah, Josie.
All right. I'm guessing it's around midnight.
Midnight. Yes, Josie, you can turn back around now.
I thought that too.
I think. Yeah, so it would be like middle of the night, midnight, because we are at our furthest point away from the sun, which is midnight. Okay? Perfect.
Okay.
Now that you know how to spin like the Earth, here's your first challenge. Slowly spin to show your partner what it would look like for 3 days on Earth to go by. Make sure you take turns.
Okay, so you start here, and I'm looking at the sun. I'm going to spin for 3 Earth days. Go ahead, guys, spin for 3 Earth days. However many spins you think that would be. and then we'll talk about it. I'm going to be dizzy by the time this is done. And I am complete and just only slightly dizzy because I didn't go that fast. So how many times did you guys spin?
3.
3.
3. Good, right? So every time we got back to where we were facing the sun, that was 1 full day. Awesome. Okay, so that was a pretty easy challenge.
Discuss these questions.
So it says, what did you do to pretend that 3 days went by? I know we all just spun in a full circle, right? How many hours was that? One spin. How much, if we were the Earth, how many hours does 1 full spin take? Fiona, how many hours does that 1 full spin take?
Hard to answer.
How many?
24.
24. 24 hours in a day. So spinning 1 full time is 24.
Yep.
Josie. Yes, ma'am. I see your hand raised.
Oh, never mind. I thought we were supposed to say how many hours it would be for 3 days.
How many hours is it for 3 days?
I'm pretty sure it's 72.
Yes, you are correct. So yeah, 72 hours. So 3 full spins would be 72 hours.
Now for your second challenge. Model how the Earth spins when the sun rises where you live.
Okay, so we want it to be a sunrise for Missouri. So we need to be where we're just barely seeing the sun come into view. So am I going to start facing the sun to see a sunrise? Where would I start facing if I want to see a sunrise? I'm actually going to need to be away from the sun, right? If I want the sun to rise, I can't be already looking at it. It's already risen. So for a sunrise, I'm going to need to, we already talked about that facing backwards from the sun would be midnight, right? So it's in the middle of the night, it's dark outside. As I start to slowly spin to my left, now remember, I've got to keep my face straight, but as I start to slowly spin, it's still dark. I still can't see the sun, not even out of my peripheral vision. I can't see the sun yet, but as I'm continuing to slowly spin right now, I am starting to get just a glimpse of the corner of my computer screen, which I am pretending is the sun. So this would be that moment where I start to see the sun come up on the horizon. And as I take another tiny step, the sun gets a little higher where I see it, and the sun gets a little higher. So do you see how as the Earth spins, it seems like the sun is rising in the sky, but it's actually just me spinning to face it more directly. Does everybody kind of understand that? So what I want you guys to do is turn around so that it's midnight. Turn around so that it's midnight. And I want you to just turn really, 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 really slowly until you can just barely see your sunshine. And then you'll see how it would be if you did a sunrise. Now remember, you've got to keep your face straight. You cannot turn your head or your neck. You have to just face straight. And then eventually you will be able to barely see your computer screen or whatever you're using as your sun out of the corner of your eye. And as you turn at that point, that is your sun rising above you in the sky. Pretty cool? Yes, no? Is that kind of making sense and helping demonstrate why it looks like the sun is moving, but it's actually the Earth? Okay. Now,
Here's what we did to model sunrise. Start where you can't see the sun model. It's night for you when you stand like this. Then slowly spin to the left until you can just see the sun. When the sun starts to come into view, that's sunrise.
I am on a virtual meeting.
Hold on for a second.
Hang on, guys, I got to mute real quick. Hang on. Okay. All right. Sorry. I ended up, I don't know what I did. Miss Watson called me. Sorry. She made me mute. Okay. So did everybody figure out and they saw a sunrise? Everybody good on sunrise?
Yep.
Okay. So when we are
Okay, for
seeing,
your third challenge,
Douglas, so when we're seeing a sunrise and I'm just barely able to see the sun rising, what's happening to my friends in China on my back? What are they seeing? I'm seeing a sunrise. What is China seeing? Grayson, what's China seeing?
Sunset.
Sunset. How do you know that it's a sunset?
Because if America is on the front of you and China is on the
Right.
back of you, and America is having a sunrise, then China will be having a sunset.
Right. So as I can barely see the sun start to come into view, China is losing the sun, right? They're turning further and further away. And in one more step, China probably isn't going to be able to see the sunshine anymore. One more step, and I'm pretty sure they're blocked. I don't think they can see the sun anymore. They're facing too far that way. It's dark for them now. All right.
here's what we noticed. When your face spins towards the sun, your back just spun away from the sun. Watch that again. Your back is going to spin away from the sun. It goes from day to night for that side. So your backside just saw the sun set. So when sunrise is happening for one side of the world, sunset is happening for the other side of the world. Does that make sense?
Good. All right.
Miss Bab.
All right,
Yeah.
so your final,
So
Yes.
right now
Mhm.
it would be nighttime for Asia. It's right now it's nighttime for Asia.
Yes, correct. So like it's 2 o'clock. So if straight ahead is noon, I could maybe take 2 tiny steps. This would be about 2 o'clock. So yeah, it's still, it would be the exact opposite. So it would be like 2 in the morning for them. So it's 2:20 here right now. So it would be 2:20 in the morning for them, like in the middle of the night, completely. Okay. Yeah, good question. So think about this. It says, pretend we've found another planet called Swiftia. Swiftia spins twice as fast as Earth. So if our Earth day is 24 hours and Swiftia is going twice as fast, how long is a day on Swiftia? What do you guys think? Fiona, what do you think?
I think that it would only be 12 hours a day. So
Okay.
it would be 6 hours at nighttime and 6 hours a daytime. Unlike Earth, it's 12 hours a daytime, 12 hours at nighttime.
Perfect, Fiona. Yeah. So if it normally takes me 12 hours to go this far and another 12 hours to go this far, but now I'm spinning twice as fast, I'm going faster. So it's not going to take me as long to get there. It's only going to take me 6 hours, 6 hours. The faster I go, the shorter my day is because I can spin around all the way faster. Josie, I see your hand raised, babe.
So I agree with Fiona because 12 plus 12 is 24. So their days would only be 12 hours in a day. But wouldn't their years be like twice as short?
Potentially, yeah. The year, now think about this though. The year is based on how long it takes them to go around the sun.
Yeah,
Not
because
happen.
ours is different than Jupiter's.
Right, yes. Jupiter's orbit is larger. So it probably takes longer for them to get all the way around the sun. So a year on Jupiter probably is much longer than a year on the Earth. Yes. Okay. Now we found another planet. I'm going to just talk instead of Mystery Doug. We found planet Snow Globe, and Snow Globe takes 10 times as long to spin as the Earth. So it's going even slower. It is taking forever. And if it's going 10 times as long, can we do the math on that? How long would it take for snow globe to have a single day? And Kaylin, is your hand raised? Kaylin, how long would it take? No, it's not raised. Josie, what do you think?
Well, 24 plus 24 is 48, so it would probably take 48 hours and 10 times. Never mind. I'm confused.
No, you're good. You were on the right track. You were just doing twice as fast instead of 10 times as fast. So if snow globe was moving twice as fast, or twice as slow, rather, I'm sorry, twice as slow, it's taking it longer to get there. So if
Their
it was
days are long.
it would be a 48-hour day, but it's going to take them even longer because it's 10 times. So 10 times 24 would be, anybody? 10 times 24? Add a 0. Cam. Do I unmute?
240.
240. It would take them 240 hours to have a single day. 120 hours of daylight, 120 hours of dark. They are moving around their axis incredibly slow. Okay.
How long is 240? How many more
Hours?
days is that on our planet?
It would be 10 days.
That
10
makes
of
sense.
our days, one of their days. Yeah. Yeah. Okay, so let's finish this video off.
So how fast does the Earth spin? Well, in the activity, you created a model of the Earth and the Sun. And by spinning once in place, you modeled the Earth's spin around its axis. Since a full day is 24 hours long, you know that one spin takes 24 hours. But how fast is that exactly? Like if we were to put that in miles per hour, the way we measure the speed of a thing like a car, what speed would that be? Well, to do that, we'd have to figure out how many miles the Earth turns per hour. There are 24 hours in a day, but how many miles are there in one spin? Put that question another way. How many miles around is the Earth? The Earth is huge. Measuring it is not easy, but scientists have been able to figure out exactly how large it is. We know that the circumference of the Earth, that's the distance all the way around the equator of the Earth, is about 24,000 miles. So then we can just do some simple math. If it takes the Earth 24 hours to do one spin all the way around itself, that's 24,000 miles divided by 24 hours in one spin. If you do the math, that equals 1,000 miles an hour. Whoa, wait a second. The Earth is spinning over 1,000 miles an hour? Now you can kind of understand why people a long time ago had such a hard time accepting this idea. If the Earth is moving at 1,000 miles an hour, why wouldn't we feel that? But as Galileo figured out, this movement is a constant movement. Everything around us here on Earth moves at this same speed. The clouds, the air, the ground, the buildings, even you, as you sit there in your seat, we're all moving together at almost 1,000 miles an hour, which is why we don't really notice it. Now, that said, you can notice the movement of the Earth's spin. It's not something you can feel, it's something you can see. This, what otherwise looks like the sun moving, is actually the Earth spinning. You created a model of this in the activity. As you stood with your back to the sun, you modeled nighttime for this side of the Earth, the side not lit up by the sun. But as you spun this way, now the sun appeared to move into your view, just as what happens at sunrise in the morning. As you continued spinning all the way to this side, now the sun appeared to move out of your view, just as what happens at sunset in the evening. The sun looks like it's moving, but it's really the Earth that's moving. Here's one more thing we can do to help us picture this. We used a globe for the Earth, a lamp for the sun, and then to represent you or me, we stuck a Lego man on the globe. We can call him Lego Man Joe. Then we filmed what Lego Man Joe would see as the Earth did one complete rotation. Let me show you. First, let's move the camera behind Lego Man Joe so we can see what he sees. There we go. Now, in a second, I'm going to start spinning the globe like this, just like the real Earth spins, but I'm not going to move the sun. Okay, let's watch what Lego Man Joe sees. Here we go.
Starting.
Here we go. See the sunrise.
Whoa.
The lamp. And he's turning. Sun is going up, up, up. Earth is turning. And I'm going to turn Lego Man Joe around on the globe here so that he can continue to watch the sun. Okay, now I'm spinning the globe again. And you can see here's sunset about to happen. There you go, sunset. So next time you see the sunrise or the sunset, think of the Earth's rotation. It's not the sun that's moving. It's you, me, and the Earth. Have fun and stay curious.
During this time.
All right. Sorry, it got like really loud in here with the announcements. Hang on.
Colby Peterson, Mallory Seltzer, Olivia Tyndall, Zoe Warren, Tyson Whitener, Alba Walk. All of you, please head to the library.
Okay, so I could see your faces as you guys were watching Lego Man Joe watch the sunrise and sunset standing on Earth. Like you guys had like this cute little grin on your face, like, wow, that's so cool. I absolutely loved every minute of watching your faces watch that. That was fantastic. Science is fun and awesome. I love it too. So let me ask you this. We practiced today spinning to the left. And when the sun rises and sets, does it always rise on the same side of the United States, or is it somewhere different depending on the time of year? Think about our directions: north, south, east, west. Never eat a soggy waffle. Okay, never eat soggy waffles. What side of the Earth is the sun always seem to rise on? Anybody know? The sun always rises where, Josie?
Doesn't it west to east?
Close. You're at least got the directions correct, like the east-west. So it rises in the east and it sets in the west. So think about this. So as we spin from left to right, it's rising on our east. I'm backwards to you guys right now. And it sets on the west. Now, is there ever going to be a time that the sun could rise in the west? Could the sun rise in the west instead? Josie, what do you think?
I actually probably don't think so, because it's not like just one day of the year the Earth will travel 20 miles per second. It's just all a big, everything is perfectly calculated to where it probably all just does the same thing. And no, I don't think that it will change ever, because that's just not normal for the Earth.
Okay. But not normal for the Earth. You're onto something there. Kane, waving like a madman again. I love when Kane gets excited with an answer. Go for it, Kane.
Okay, I was just messing with my globe over there, and I acted like my hand was the sun. And when it came west, and then it set in the east, and then it rose in the east for Asia. So
I think you've got your directions. I think you've got your directions mixed up. The sun always rises in the east. So let's think about this, okay? Let's put the directions. Look at just watching me, okay? Let me make sure my camera's like really on me, okay? So we'll put north on my head, right? North is up here, and we'll put south here. And then what? I'm trying to do this in your direction. East, correct? And west over here, okay? So I'm going to hold my hand for the east. So then as I'm spinning around, my hand held up is the east, okay? You see me spinning my hand. Okay, but so here comes the sun again. The sun is rising on the east, right? You guys see the sun is rising on my east because I'm spinning this way. And I see it, but now the east side is going away. So it's setting, the sun is setting on my west side over here. If I wanted the sun to rise in the west, I would need to spin the opposite direction.
The thing I don't understand is,
so can the earth just stop and then spin the opposite direction? No, that's not going to happen. That's where Josie's like, because it's just the way it is, science. Yes, the earth only spins in that one same direction at a steady pace. So the sun will continue to always rise in the east and set on the west. And that will be true no matter where on the earth you are. Okay, Josie.
so the thing that's confusing me, isn't it north, east, south, west? The way you were doing it was northwest, south, east. Isn't it like that?
Am I not being projected backwards towards you guys? Yeah, Josie, what you're showing me is correct. What you're showing me is correct. I was doing it backwards to myself because I thought that you guys are getting a mirror image of me. I thought I could
It was
be wrong.
confusing because
You're
like,
not.
this
Okay.
was north,
And
that
east
was
should be
south.
over here. So this should be my east. Is this east?
Yes,
Is this east for you guys?
that's east.
Okay. So then, yes. So then sunrise would be, yeah. I'm doing it backwards left. Okay. All right. So yeah, so yes, you were right, Josie. I did it. I spun the wrong direction. I had my east and west mixed up. Okay. So you were correct. So this is east, north, east, south, west. You got it. Never eat soggy waffle. We got it. Okay. East. And so the earth, and that's what they told us to do, right? Spin to our left. So I'm spinning to my left. I'm spinning to my left. I'm going a little faster. Okay. Here's my sunrise. It's happening on the east. I'm seeing the sun come up. I'm seeing it. Okay, now it's like fully up. It's like lunchtime. And now it is sunset. I'm losing it. This is my west side. And the sun is going down on my west side. Okay. So no matter where you are on the earth, whether you're Missouri, China, or somewhere in between, the sun always rises in the east, sets in the west. And unless there was some catastrophic event that caused the earth to stop spinning and change direction, which I think we'd have bigger problems than just changing sunrise and sunset at that point. That's the way it's always going to be. All right. So that is the end of this lesson. You have an entirely another mystery science lesson that you will be doing kind of on your own tomorrow. And it's going to go into a little bit more detail with shadows and whatnot. Josie.
So this one's just going to talk about shadows, right?
It's going to go into shadows and hang on. Where's my mystery science? Okay. Hang on 2 seconds, Josie, and I can tell you the next lesson is the Earth's rotation, which is the spinning, and how the Earth's spinning affects the shadows. Okay. Okay, so how Earth's spinning affects the shadows and the time of day. Okay, so that the time of day is actually, we're going to go more in depth on the time of day as the Earth spins. Cam, what's your question, babe?
Was that the entire assignment, or do we have anything else on Seesaw?
For today, you are done with science for the day.
Okay.
So tomorrow, and I may actually upload the other science one today. So if you want to get started on the other science one right away, you can. And then your thing will be first do the other mystery science video. And then Monday, you will have a quiz, and that quiz will be over both of the mystery sciences together.
Got it.
So today's mystery science, tomorrow's mystery science, and then on Monday, Tuesday, Wednesday, you'll have a quiz that goes with both of the mystery sciences. Okay.
Okay.
So For now, it depends. It's like end of day. They're about to call for buses and stuff. So I don't know if I'm going to get the second one uploaded today. But if I don't get it uploaded today, I'll do it first thing in the morning for you guys to work on, so that you have that next mystery science to get going while you still have science in your brains. Okay. All right. I think that's all I've got for today. So I will plan on seeing you guys again in the morning at 9 o'clock again for reading. You guys have a good night. Bye-bye.
Bye.